It's another math day here with teacher Jenny. Join me for another topic. This time we're going to talk about derivatives. So we'll do some optimization here in this problem. So we have a rectangular garden has a total perimeter of 36 meters. Let the length of the garden be x meters and the width be y meters. What dimensions will maximize the garden's area? Take note, we are trying to maximize the garden's area. So, basically, we will be solving the derivative because once we say maximizing optimization, we will be utilizing the concept of the derivative there to find our critical value first so that we can name it as our maximum point and minimum point later on. So that once we wanted to find whatever value maximizes that particular quantity, then we could answer that one using the concept of the derivative and so with a critical value. So we will start with solving this one and knowing what are the different formulas that we wanted to use. If we wanted to recall a rectangular perimeter, we have that one as P will be equal to 2L plus 2W. And then our area of a rectangle is L times W. Now, if we let our X be, according to the problem, be the length, and then our Y be the width, and we are given that P is equal to, or the perimeter is equal to 36 meters. So all we have to do is to just simply plug in that information first. Here we have our P that will be equal to our L, or length is X, plus 2W. Our P is 36 based on the problem. So we'll be replacing our P here by 36, and that's equal to 2x. And by the way, the W there is going to be replaced with y, according to the problem, and so with the one that we let a while ago. So since we have this information, and we know that the area is equal to x times y, then we will be solving first this one here. We can solve for y in terms of x and then replace that afterwards to our area that we wanted to maximize with. Replace the y there so that we are only left with an x. So here, since 36 2 and the other 2 is going to be with a common factor, which is 2, we'll be reducing this one. So we divide this by 2, and so with this one and this one. So 36 divided by 2, that's 18. That's equal to 2x divided by 2, that's an x, plus 2y divided by 2, that's a y. So we can solve for y once we are going to move x to the other side by simply subtracting that by x. So this is now our y. So going over to the area will then be equal to x. Our y is going to be replaced with 18 minus x. And then we distribute x here. X times 18, that's 18x. And then x times negative x, that will be negative x squared. Okay, right from there, we start with getting our derivative because we wish to get our critical value so that we can distinguish whether that is maximum or the minimum. So getting the derivative, that will be equal to derivative of 18x, that's 18, minus derivative of x squared, that's 2x. After having the derivative, we are going to set our a prime to 0 because finding the critical value would mean that our slope or the derivative there is a 0 or undefined. So we set our a prime to 0. That will be equal to 18 minus 2x. We solve for x by moving 18 to the other side by subtraction on both sides. So this will be minus 18. I mean, negative 18, that's equal to negative 2x. Dividing this by negative 2 to get our x. Our x there is equal to 9. Or our x is the length. The length there is 9 meters. And then, to check whether this is maximum or minimum, because our aim here is to maximize. If we don't have a maximum value here, that means to say we cannot maximize the area. So we'll better check our value x here, the critical value, whether that is a maximum or minimum, by simply doing the first derivative test, wherein we've got the 9 here, and then this is our number line. So out from there, we have to test out the different regions where our number line was divided by a 9. So we'll start off with our first derivative is 18 minus 2x. We get values here from the left side of 9 that we will be replacing our x with and checking whether it's positive or negative. So for me, I think it's going to be easier if we get the 0 here on x. So a prime equal to 18 minus 2 times 0. This will give off a 0 on the second term. So this is 18, which is positive. So whatever values we're going to get x here, it will always be giving us a positive value. So next, we are going to test out the next region. So we're using again the first derivative test. So a prime, that's equal to 18 minus 2x. 18 minus 2, we're gonna get a value here right after 9 or at the right side of 9. So that could be 10, 11, 12, or whatever you've got. And an a prime here is 18 minus 20, wherein this will give off a negative result. So negative 2. So that means this is negative. So checking up whether this is maximum or minimum, this is positive. That means to say we are increasing. And then negative here, that means to say we are decreasing. So this is clearly seen that our 9 there is a critical value which give off a maximum value. So we need to say, maximizing our garden's area, we will be needing a length which is 9 meters. And then we are going to go back to y so that we can have our other dimension or the width. So we have y equal to 18 minus x. So if our x is 9, so 18 minus 9, our y is also a 9 meters. So maximizing the area there, for the rectangle, we need 8 as our length, 9 as our length, and 9 as our width.